Have you ever wondered how electrical currents navigate through a conductor? The answer lies in a fundamental principle of electrical circuits known as Ohm's law. Named after the German physicist Georg Simon Ohm, this law describes the relationship between voltage, current, and resistance in an electrical circuit. Ohm's law states that the electric current passing through a conductor between 2 points is directly proportional to the voltage across the 2 points. This proportionality introduces a constant, the resistance, leading us to the 3 mathematical equations used to describe this relationship. Output: the first equation, V equals I multiplied by R, indicates that voltage V is the product of the current I and the resistance R. The second equation, I equals V divided by R, shows that the current is the voltage divided by the resistance. The final equation, R equals V divided by I, tells us that resistance is the voltage divided by the current. In these equations, I represents the current flowing through the conductor, V is the measured voltage across the conductor, and R is the resistance of the conductor. More specifically, Ohm's law states that the resistance R in this relationship remains constant, independent of the current. Output: however, if the resistance is not constant, then the previous equations cannot be called Ohm's law. Yet, these equations can still be used to define static or DC resistance. Ohm's law is an empirical relationship that accurately describes the conductivity of the vast majority of electrical materials across several orders of magnitude of current. However, some materials do not obey Ohm's law. These are termed non-ohmic. To summarize, Ohm's law is a fundamental principle of electrical circuits that describes the relationship between voltage, current, and resistance. It provides us with 3 mathematical equations: V equals I times R, I equals V divided by R, and R equals V divided by I. These equations help us understand how electrical currents flow through a conductor. However, they are only applicable when the resistance remains constant, independent of the current. If the resistance is not constant, these equations can still be used to define static or DC resistance. Finally, while Ohm's law accurately describes the conductivity of most electrical materials, some materials do not obey this law and are termed non-ohmic. Remember, understanding Ohm's law is crucial, not just for physicists or electrical engineers, but for anyone interested in understanding the world around them. Because after all, our world is powered by electricity, and Ohm's law helps us understand how it flows.